Hello and welcome to Screencast 13, Topology Today. What do I mean by topology? In this case, I mean the relationship of one moving part to another. So for example, it could be a CICS region attaching to an MQ queue manager. But it doesn't have to be an address space. It could be something like a DDF client out on another machine somewhere connecting somehow into DB2. I'm tempted to use the word architecture here, but there are two reasons why I don't do that. One is it sounds overly fancy, and in fact topology I'm a bit self-conscious about anyway, but it's the best word I can come up with. The other reason though, which is probably the more serious one, is that the kind of topology I'm talking about is just a part of architecture and not all of architecture, so it wouldn't do to use the term architecture here. Of course, the thing to do with open sets is a completely different kind of topology. Why does topology in this sense matter? Well, it enables us to understand more about the role of moving parts. For example, what is this CICS region for exactly? It enables us to see those moving parts that have the same topology. So, for example, you might see an array of cloned CICS regions. And equally within that, you might see balance or imbalance between those cloned CICS regions. So understanding the cloning and the topology is quite useful here. Sometimes it enables us to see useful performance information. And I'm going to present two scenarios today, so enough of the words, we'll get onto the pictures in a minute. The second one is an example where maybe this information is useful for performance matters. And finally, and perhaps overarching, understanding topology in this sense enables us to make better architectural decisions. So there's a number of reasons why this fairly dry topic matter. This screencast focuses on the SMF30 usage data section. For those of you who don't know, the SMF type 30 record is an address space record. There are a number of flavors of this. For example, we have interval records cut on every SMF interval, typically every 30 minutes, and those would be subtypes 2 and 3. Equally, we have step end records, subtype 4, and job end records, subtype 5. In fact, every address space just about will cut a subtype 4 or a subtype 5 when it comes down. Here we're specifically interested in the usage data section. You get one or more of these sections in an SMF30 record per registered product. So if we take the example of a CICS region, you would have one of these sections documenting CICS itself. And if that CICS region connected, let's say, to a DB2 subsystem, we would have some sections documenting connections between that CICS region and the DB2 subsystem itself. Each of these sections has a number of fields, but most notably we have the vendor. In the case of CICS and DB2, of course, it would be IBM. We have the product name, so we would have CICS and we would have DB2. We have a subfunction, which I'll come back to in a moment, and we have a release level. The subfunction varies in its structure. So for a DB2 section, it would simply be the name of the DB2 subsystem, and you can see where this is going. For MQ, it would be encoding of the subsystem name plus a suffix which relates to how, in this case, the CICS region connects to the MQ queue manager. So you can see we have the basis for topology here. Now sometimes we actually have the CPU used in the product in the section. And we'll talk about this later on in this screencast. So onto some diagrams. So this is from a real customer. I've changed the names a little bit. This is an example of CICS regions talking to DB2. And it could be MQ, or you could, as indeed our code does, establish CICS regions that don't talk to either DB2 or MQ. Now here we have four systems: CIS-A, CIS-B, CIS-C and CIS-D. Each of these systems has two DB2s, and you can see that's the second layer of each tree. And at the bottom layer, of the leaf nodes, if you like, of the tree is the actual CICS regions. Now I've color-coded these because I've attempted to glean some kind of structure out of this. So already you could see this could be a basis for discussion with a customer of what their DB2 subsystems are for and which CICS regions attach to which ones, and maybe we learn something about the naming convention in the process. I find when I do this with customers, and this is not the only customer I've ever done this with, that this sort of diagram starts a conversation that brings the estate to life. Always a useful thing to do. I've drilled into a pair of DB2 subsystems here, and I've done this because you probably couldn't read what was on the previous slide. So here, quite clearly, we can see naming conventions. We can actually see for the CICS regions that connect to DB2s in CISC that we have a C in the region name. Equally, you can see that for CISD, there's a D in the same spot in the region name. So there's a naming convention emerging right there. And if you look at the color coding, you will find that it's a reasonable color coding of like-named regions across these two DB2s and these two systems. And remember, the previous slide had basically 4 systems with 8 DB2s in. The naming consistency here is really rather good, even if I can't say the word consistency to save my life. Here's another example. It's actually relatively recent, even though the timestamps in the data would indicate it wasn't, maybe. So we have a batch job here. And looking at one step, and this is from the step end record, the subtype 4, we see step 3 and we see the timings for it. So it ran for about 46 minutes. And we have total TCB time, or CPU if you prefer, of just under 3 minutes. What I have taught my code to do is to list any usage data sections that this step has in its type 30 record. In this case, there are 2. So the first one is a DB2 subsystem called DB2V, and that subsystem is at version 11. I've done a bit of work on the version field in the usage data section in my code to try and make it more sane to read out. So here we've got a DB2 version 11 subsystem called DB2V, and we'll talk about the TCB time in just a second. Below it, we also see that this step connects to an MQ queue manager called MQS1 at version 8. Now this is quite useful to know these things, firstly because we ought to be looking for a counting trace from that DB2 subsystem in this time frame to be able to explain the DB2 portion of the time. And secondly, knowing that a step connects to MQ is kind of handy because it might explain some of the elapsed time we otherwise can't explain. Which brings me on to TCB time. Concentrate on the MQ queue manager line for a second. So my code, rather smartly I feel, says the word all. That basically says that all of the step TCB time was using MQ. That suggests to me that a very large proportion of the elapsed time is related to MQ. It's not a dead cert, but it seems very likely that that would be the case, which I think is a soft-pedaled insight of some sort. You'll notice, however, against DB2V, that the TCB time has got a question mark. And that is because we don't actually know the time in DB2 in this case, unless we went off to a counting trace, which is the subject of another topic, I would have said. And this is because most DB2 subsystems in most customers that I know of don't actually allow DB2 to record its TCB time in the type 30 or indeed the SMF89 record at all. So we don't know it. Now, you probably spot a tiny flaw in my programming here. Given that we know all the CPU time was in fact in MQ, maybe we should write a big fat 0 against DB2V, and that would be fair, and maybe one day I'll get round to fixing that little nit. Meanwhile, you can all have a laugh at my expense. So this screencast has been a quick canter through some of the value of the SMF30 usage data section, in particular understanding what connects to what, and I hope you've enjoyed it. If you have any feedback, please send it to me. I am Martin Packer on Twitter, or martin_packer@uk.ibm.com. And thank you for listening and watching.